Hi guys, good afternoon. So in the last session, we saw about your passive interface concept. We saw about how you can enable OSPF. Okay, and also we saw about the neighborship criteria, network types. This was the part. Now today, let's go to the next thing. And before that, we have OSPF, DR, and BDR concept. Now, what is OSPF, DR, and BDR? So, what do you understand with DR and BDR? DR is to reduce the number of LSAs in the network. Number of LSAs. Okay. And when there is a completely change or the new interface comes up, so all the routers will send LSS to their neighbors. So to reduce that traffic, we need a DR and BDR. Every segment, every subnet should have one DR and one BDR. Every subnet should have one DR and BDR. Does it depend on network type? Yes. Yes. Only in DMA and NDMA networks, your DRBD elections will take place. Okay. So let me open the book. Yes. Any doubts? This is the CCI book we will refer. Then we have routing book. And we have OSP. Areas, allopathic neighbors, enabling OSP of multi-area. So normally what happens that when we connect routers, so generally we connect it point to point only, right? But there can be some sort of multi-access networks. Now, what are multi-access networks like Ethernet LAN and frame relay, which is an older technology. So they can have more than two routers to exist on the same segment. That means might be possible that there are more than two routers on the same LAN segment or in the same segment. More than two routers are there. So what will happen if there are more than two routers? So if you consider the scenario, okay, we are talking about OSPF, DR, and BDR. So make the heading OSPF, DR, and BDR. That is designated router and backup designated router. Okay. OSPF, designated router and backup designated router. Okay. Now, if we consider a scenario, so first before that, let me give a note that DRBDR election will take place only in the DR and BDR election happens at two-way state only. Okay. And also DR and BDR election takes place in DMA and NDMA network types. Okay, in other network types, there will be no DR or BDR elections. Okay. Now, let's consider a scenario I have a switch. And with this switch, I have 5 routers connected. R1, I have R2, okay, like this, I have 5 routers. So this is R1. Okay, say this is R2, R3, R4, then R5. Okay, then switch. Yeah, and consider everybody's in same area. That is, let's say area 0. Everybody is part of area 0. Now what? If I configure them, let's say here, this is the IP address 10.1.1.1. This guy has an IP address 10.1.1.2. This guy has an IP address 10.1.1.3, 10.1.1.4, and this guy has an IP address 10.1.1.5. Like this, the IP addresses are there. Okay. And if we configure OSPF in all these routers, now what is going to happen? They all will become neighbors. Right now, we are not considering the DR BDR here, just normal OSPF. And if DR BDR is not there, everybody will form full mesh neighborship or full mesh adjacency. That means full adjacency they will form. They will form full adjacency. Now, since full adjacency will be there, that means they will be exchanging the database and everything. Correct? So if we talk about like who will be the neighbor for R1, if I say that okay, for R1, who will be the neighbor? So if we talk about R1, for R1, R2 will be neighbor, R3 will be neighbor, R4 will be neighbor, and R5 will be neighbor. For R2, who will be the neighbor? R1, R3, R4, R5. For R3, who will be the neighbor? R1, R2, then R4 and R5. For R4, who will be the neighbor? So R1, R2, R3, R5. And for R5, who will become the neighbor? R1, R2, R3, and R4. Correct? This will be the scenario. This will be the full neighborships. Okay. Now what? Here what is going to happen? Let's say on R1, there is a new network added. On R1, there has been a new network added. So now it's responsibility of R1 to inform all its neighbors about the change, right? So what R1 is going to do? R1 is going to inform. So R1 is going to inform everybody. It's going to inform R2 also, R3 also, R4 as well as R5. To everybody, R1 has informed. Correct? Now, what R2 is supposed to do? R2 is also supposed to inform all its neighbors, but due to split horizon rule, it will not send the same update back to R1. Right? So that means when R2 will share this information, so that information will be shared to, let's say, R3, R4, and R5. Correct? Okay. Then same information from R1 was received by R3 as well. So that means R3 will also inform all its neighbors. So R3 will inform R2, R4 as well as R5. Correct? Same information from R1 also came to R4. So R4 will also advertise it to its neighbors. So R4 will inform to R2, R3, R5. Correct? And same information from R1 also came to R5. So R5 will also inform all its neighbors. So it will say to R2, R3, and R4. Now this was the update only coming from R1. Now imagine R2 also shared, R3 also shared, R4 also shared, and R5 also shared. How many updates, how many LSAs will be flooded in the network? That is a useless bandwidth consumption and also CPU consumption because all the routers has to process the packets or the LSAs, right? So to why this kind of thing is happening? Because of full neighborships or full adjacencies. Because they are forming full adjacencies. So to reduce the number of full adjacencies in OSPF, we have the DR and BDR concept. So what will be the outcome of having less number of full adjacencies? Less LSAs will be flooded. Less number of LSAs will be flooded. This is clear? Okay. Problem is clear? Now. So take a look here. Additional routers, they will flood more LSAs on the segment and OSPF traffic becomes excessive as OSPF neighbors adjacencies will increase. We saw right now that only from one router we saw, but still there were so many updates. Then if we consider R2, R3, R4, R5, everybody will keep on exchanging. So what will happen? There will be an excessive OSPF traffic. Okay. And why this is happening? Because of OSPF neighbor adjacencies increasing. Okay. So the DR and BDR reduces the number of OSPF adjacencies in the multi-access network segment because routers, they are going to form full mesh adjacencies only with DR and not with each other. This is clear? So note down this point for why DR and BDR is there. Okay. So we can say here that the designated router reduces the number of adjacencies in the multi-access network segment. Why? Because routers will form full mesh adjacencies only with the DR, BDR, not with the each other. Okay. Let me explain. This thing is clear. Now, what is happening that DR, BDR is getting elected. BDR is getting elected. So how the DR, BDR election takes place? Okay. So the first thing is what? That first it will select highest priority. First, it will check highest priority. Then, if priority is a type, in that case, highest router ID will be elected as the DR. Okay. So this is the election. You can see that the DR BDR election occurs during the OSPF neighborship. Okay. And specifically during the last phase of the two-way neighborship state and just before the extra. So that means between two-way and extra, the DR BDR election will take place. Okay. All the routers, they have OSPF priority, and your OSPF priority can range between 1 to 255. Okay. So on its OSPF interface to become DR. And by default, what is the priority of all the interfaces? By default, the priority is 1. Clear? So routers, they will receive and examine the OSPF hellos. This priority information will also be shared. Okay. So OSPF routers, they will receive the hello from the neighbor and they are going to examine it. And if a router finds itself as a more favorable router than the OSPF hello it receives, it will continue to send out hellos with the router ID and the priority list. That means all the routers, they will inform about the priority also. Yesterday we saw, right? The OSPF hello message contains, if you remember, we have router ID, we have authentication, we have area ID, interface, and also we have interface priority. So all the routers are exchanging this information. So they will see that, okay, whether it's equal or somebody is superior or not. Okay. And if this is a type, then they will start checking router ID. Yeah. So everything will happen within the hello message itself. Okay. So if a router identifies itself as a more favorable router than the OSPF hello it receives, it will continue to send out hello with its router ID and priority list. And if the hello received is more favorable, that means somebody else is more superior. In that case, the router will update its hello packet to use the more preferable router ID in the DR field. Because if you see here in the hello message itself, we do have the DR information also. See here, designated router and backup designated router. That information is also there. So in this field, they will use the IP address of the DR. Yes. So if the router, if the hello received is more favorable, the router will update its hello packet to use the more preferable router ID in the DR field. Otherwise, by default, it will use its own. By default, it will use its own. OSPF deems a router more preferable if the priority for an interface is the highest for that segment. And if priority is the same, the higher router ID is more favorable. Okay. This is clear. When all routers are agreed for the same DR, all routers on that segment will become adjacent to DR. That means they will form full mesh neighborship. Then the election for BDR will take place. The election follows the same logic as the DR election, except that it does not add its router ID to the BDR field of the hello packet, because everybody will include the information about DR only. Okay. And in case DR is not there, in that scenario, BDR will come into place. Okay, and the BDR election will take the same steps. Now, this is clear how the DR BDR election takes place. So BDR is already up. Both the routers are already up. But
तो मतलब बीडीआर डाउन हुआ तो मतलब बीडीआर कैसे एडवर्टाइज करता है कि मतलब
BDR is not advertising. Everybody knows that this guy has the second highest router ID. Okay. So when a DR is down, only election for another DR will take place. BDR will take the responsibility. Okay. If BDR is down, election for BDR will take place.
बीडीआर इलेक्शन करवाया बीडीआर के लिए
If DR is not there in that case, BDR is there. That is why it is known as backup. Okay. This is clear. Okay. Now, let me explain once the DR BDR election is happening. So in our scenario, if we see here that everybody will have a priority by default one, this guy has a priority of one. This guy has a priority of one. This guy has a priority of same one. This guy also has a priority of one. And this guy also has a priority of one. So that means everybody is having the same priority. So if everybody is having the same priority, that means the election will take place based on router ID. Now, who is having the highest router ID? R5. So that means R5 is going to become what here? This guy will be DR, designated router. And second highest router ID, this guy. This guy will become BDR. Correct? Okay. Now, once we have DR and BDR placed here, okay. After that, everybody else, they will be what? They will be taking the role DR other. This is also DR other. This is also DR other. This is also DR. They have taken a role of DR others. Now, remember this thing that a DR, if we talk about the neighborship, if we talk about the neighborships, so between DR and BDR, the neighborship will be full. Okay. Between DR and DR other, the neighborship will be full. Or let me say both DR BDR, so that it will not take more number of lines. Okay. Then between DR other and DR other, the neighborship will remain only in two-way state. There is no full neighborship. So if there is no full neighborship there, that means there is no database exchange, because in two-way state you exchange only hello messages. You do not exchange any other information. You only exchange hello messages. Correct? Okay. So we have elected DR, BDR, everything. Okay. Now, again, if there is a change on this guy, so this guy will inform only DR and BDR. So that means this update will be sent only to DR and BDR. Is it really going to happen? Does it really happen that the update only goes to DR and BDR? Okay. But they won't process. Let's say, for example, let's consider as of now, it will go only to DR and BDR, just to understand the logic. That the update is only going for DR and BDR. Now what will happen? As long as your DR is available, your BDR is not going to say anything. Your BDR will remain silent. As long as DR is present, BDR is not going to say anything. So what will happen now? It's the responsibility of DR. So DR is going to inform same thing to everybody. To this also, to this also, to this also, to this also. And everybody is going to accept this. And since these guys, they have received from the DR only, they are not going to send it back to DR. They are not going to send it back to DR. This is clear. Okay. Now comes the question. That how this update is going only for DR and BDR. Okay, so you say that okay, this packet will be destined to 224006. No,
See for here only. Five is for all.
you tell me,
Five for all.
5 or 6.
Five for all. Six for here and there. But here, when here and then, it will be 600.
What it says, OSPF uses two multicast addresses 224005 for all routers and 224006 for DR and BDR. So this means what? That whenever the traffic is going for all OSPF routers, the destination address will be 224005. When the traffic is going for DR and BDR only, the address will be 224006. Clear now? Okay, so this is having destination address 224006, which is a multicast. How switch deals with a multicast? How the switch deals with the multicast traffic? Idea? Now multicast is on layer 3, right? 224006. How switch will understand that okay, where I have to send? So switch does it same as a broadcast only. Switch will send to all the ports. Switch will send to all the ports to everybody. Okay. So what it is going to do here, it is going to say here as well. Switch will send it here also, here also. But the thing is, these people will drop it. This guy is going to drop it, this guy is going to drop it. And if you talk about your DR and BDR, so DR will accept it and BDR will also accept it. Now, why like this? Why DR, BDR will accept and why DR other will not accept? And how do you know not for them? So, it's not about neighborship. The masses have arrived, right? Why they are going to drop it? Network type doesn't have anything to do here. What do you understand with a multicast? Let's say 224005, 224006, 224009, 10. What do you understand with that? Because in AGNP I explained this, that's why I'm asking. What do you understand with that address? Remember, I gave you a task in AGRP that what happens when you give a network statement in AGRP. So what happens? Correct. AGRP will be enabled. The AGRP will start sending hello messages on the interface, right? And that interface will start listening on address 224010. So that means here these routers R2 and R3, they are not listening on that address. Let's say, for example, a postman, if he gives you a, let's say, some postcard that is not destined for your home address, will you accept it? No. You will not accept it, right? Because that doesn't belong to you. You will say, no, this is not mine. Maybe next door or somebody else. But this is not mine. I will not accept it. So you don't accept the post. Router won't accept the packets. Understood? So these people, R2 and R3, they are not even listening to that address. Let's say, for example, do you get, let's say I have 11 a.m. also, I have a routing batch. So do you get the updates or messages, whatever I drop in that group? No. Why you do not get it? Because you are not member of that group. Same way, these multicast addresses are individual groups. These multicast addresses are what? Individual groups. So if you're not member of a group, you're not going to get that message. Is that clear? Okay. Online people clear?
Yes, sir.
Okay. So this will be the scenario how the update will travel only for DR and PDR. Okay. Then when DR is sending this update, now this update has to go to everybody. So that means here the DR will use what? The address, destination address 224.0.0.5 because everybody is listening to this group. Everybody is member of this group. Everybody is listening to this address. That is the reason that this will travel to everybody. This is clear? Right. Yes, router 1 also. Our router 1 will come to know that, okay, the update has gone to the DR or not. Okay. And this is how it is going to happen. Yes. Okay. Now, let's say if you want to manipulate DR action, so what we can do, we can go and change the priority. We can manipulate the priority. So if we manipulate the interface priority, then what we can do, we can change the DR action. So priority range is what? Between 0 to 255. The priority range is between 0 to 255. So if I set priority 255, that guy will become the DR. If I set priority to 0, exactly. The router is not going to participate in the DR and BDR election. That means that guy will never become a DR or BDR. Yeah. So any case, that is up to you as per your requirement. Okay. Let's say you have 10 routers and out of the 10 routers, one of the router is having, let's say, for example, these are the routers. Okay. Out of these routers might be this is the router who is connected to the ISP. So I want that, okay, everybody should inform this guy. This guy should have all the routes. Then what can I do? I can configure this guy as a DR. So those are scenarios. So as per your requirement, we are going to make changes in this. Now let's go to the lab. Basic multi-area. Don't we have DR video? So we'll take 5 routers. These are the 5 routers. Then we need a switch. Okay. So same kind of network we'll use 10.1.1.0/24. Okay, this is the network we'll be using. Here we have 10.1.1.1. Then we have 10.1.1.2. And 113, 10.1.1.4, 10.1.1.5. Okay, and here our space area. So this is what we have to configure. Clear? Okay, who will do the configuration? Who wants to do it? No one? You can do it. Complete configuration with OSPF. Take the mouse if you need.
मतलब
Done. Okay. So now R1, R2, R3, R4, R5. R5 already done. Okay. So everywhere what I'll do is I'll start the debug also for adjacency. Okay. Now I'll paste the configuration. So this is R1, R2, R3, R4, then R5. Okay. See here, they are in state 2 with everybody. Then end of wait on interface, DR BDR election, elected DR. Sorry. So first of all, it selected it as a BDR, then it elected it as a DR. Okay. Prepare the database exchange, then it will use, the DBDs and everything. Okay, they are exchanging the database with the DR and BDR. See here, now the correct information. Elect the BDRS 10114 and elect the DRS 10115. Okay, so it has synchronized the neighborship as full with the 10.1.1.4. Full neighborship, R1 full neighborship with 10.1.1.4. With the DR and BDR, they will have full neighborship. Okay, and earlier we can see that here you can see that with 10.1.1.5 also full neighborship. Clear? Okay. Same thing R2, R3, everybody will have, and R4, this guy will have full neighborship with everybody, right? Okay. Now we know that who became the DR? R5 became the DR. Let's see. To show IP OSPF neighbor. So I can see that R1 has two-way neighborship with R2, two-way neighborship with R3, full neighborship with R4, full neighborship with R5. R5 is the DR and R4 is the BDR. Now what we'll do, we'll create that scenario again. Which scenario? Where we advertise one network here and we'll see that, okay, what is going on. Okay. So one thing I'll do is I'll go and capture the packets on the Z0x0 interface. Okay, we can see all at OSPF hello messages are traveling, right? So let's look only for OSPF. Only hello packets are there as of now. And here, I want to show you that, R2, R3 will also get the packets. So what I'll say debug IP packet detail. To do, I have to use. Okay. So now what will happen? Whatever the packets will come, so those packets also we will see. So right now I can see that 10.1.1.4 and everybody is sending packets at 224.0.0.5. These are the OSPF hello messages. Okay. All right. Now, let's advertise a network here. Okay. And here also, let's say debug IP OSPF events. Do I have to use? And also IP packet. Debug IP packet. Okay, typo. Okay, debugging started. Hello messages we are getting. Now what I'll do on R1, I'll add a loopback here, okay, on R1. So I'll say interface loopback 1, IP address 1.1.1.1, 255.255.255.0. Then I'll say router OSPF 1 network 1.1.1.0.0.0.0.255 area 0. Correct? Let's see. Copy. Done. Okay. Now we'll take a look. See here. The source is 10.1.1.1. Okay. Then destination IPs. It is multicast protocol number OSPF, and it's sending a either broadcast or multicast. Understood? And do you see after that what happened? See here. This was your DR who sent a response on the address 224.0.0.5. This thing is clear. Let's see if R3 received it, the 224.0.0.6. But here we will not be able to see because R3 will drop it. R3 will not accept it. In the logs, yeah, you can see here. Sources. Wait a minute. We are looking for the packet from 10.1.1.1. Okay, so what I'll do is I'll show you in the packet capture. Okay, here is not open. Okay, so I'll remove it once and then I'll add it again. And see, first let's take a look here what happened. So we can see there was an, this is the acknowledgement. You can see this is the update from 10.1.1.1. And this is going for 224.0.0.6. Same time, every day. Exactly 3 o'clock. Everything down. I will open it only today, everything is down. Then we'll have to restart the lab if server is down. Let's pause the recording, otherwise. So understand. What we saw here, that okay, who is listening? So there are two multicast groups. Okay. Number one, 224.0.0.6. So who is listening to this group? Your DR and BDR. Or you can say who is the member of this group? Your DR and BDR. And if we talk about 224.0.0.5, so everybody is member, your DR also, BDR also. What happened? Hmm? Is it in our classroom or where? Outside or UPS we have? So is it the UPS or the outside? I think that one. UPS. Scary, huh? Hmm? Okay. So these are the multicast groups 224,005 and 6. Then other than this, okay, next let's talk about the OSPF authentication. So your OSPF supports 4 types of authentication. Okay, number one, null authentication, which is by default. Then we have plain text authentication or clear text authentication. Then we have MD5. Then we have okay. This is clear. We can enable your OSPF authentication. So we can say OSPF authentication can be enabled globally as well as per interface basis. Or instead of globally, we can say area wide. Area wide as well as per interface. But there is a condition that the password that you want to configure for OSPF, right? And the password for OSPF authentication will be configured on the interface only. The password you can be configuring only on the interface. Okay. Now, one by one, we can see about the authentication. So first is null authentication. That means no authentication at all, which is the default case. Then clear text authentication is there. So clear text authentication means what? Your password will be shared in the clear text. And MD5 and HMAC, these are the hash passwords. They will use a message digest. Okay. So let's see about server. Still didn't come up. Okay, note down the comments. So first is what? Null authentication. This is the default. Here, no password is configured. Okay, here there is no password. That means password is what? Null. Okay, then we have clear text. So clear text authentication, if you want to enable, here the authentication password authentication will be shared in clear text. Okay, it is vulnerable to man in the middle attack. Okay, so if you want to enable it, you will say, if you want to enable it like area wide, in that case, router OSPF, you will give the process ID and you will say area ID authentication. Okay, and for interface, so you will go to interface name. Then what do you say? IP was PF authentication. Then you give the password. This is how you're going to configure it. Okay. Tomorrow onwards, we'll have session with a new server so that it won't go down. Okay. This is clear. Now, if you want to go with the MD5, So you can say here in the authentication password are shared in hash format. Then you can say it is secure compared to clear text authentication. Okay, clear. Now, how do you enable it area wide? So you can say router OSPF process ID. Then you will say area ID, authentication, and message types. And then if you want to enable it on interface, then you will say authentication, message digest, and area ID authentication. Instead of this, message digest key, and then the key number you will give. And then you will say MD5 and the password. So the hash value, whatever the hash value is there, that hash value will be calculated with this key number and password. Okay. So you can see the hash value is generated with the key number and password. Got it? Then we have number 4, let's make sure 256 authentication. This is even more secure than MD5. Okay. And this also uses hash value instead of password. Okay, so this will also use hash value. Here, what we'll do, we'll configure keychain. So you will say keychain and your keychain name. Then you'll give the key ID. Then you'll give the key string. And in front of the key string, you'll give the password. And here itself, you are going to give what? The cryptographic algorithm. Cryptographic algorithm is, let's make sure, 256. Then you will say interface name. and then we will apply it. Okay. IP OSPF, authentication, keychain, and your keychain name. Got it? Done. Start all the notes. R1, R2, R3, R4, R5. See if we have the configurations. Okay, so let's copy paste the configuration. Copy, paste. Copy, paste. So let them elect their BDR. They are forming the negotiate. So now if I check do show IP OSPF neighbor, you can see, right? And one thing we were trying was that whether the update is going to R2 or not, right? So this thing we have to check. So I'm capturing the packets here and only OSPF packets. Now what? We'll go to the R1 and we'll advertise the network or the loopback. Okay, paste it. So now if I take a look here, you can see this was R2's capture. So from 10.1.1, the update came for R2 also, but R2 did not accept it. Okay. And if you see what was the information inside this packet, the information inside this packet was regarding 1.1.1. This was the information. Correct. But after that, when my DR is sending the information, do you see any change in these two messages? Content is same. But if you say the source IP is different. Because DR will replicate exactly the same message only. There is no changes. The same update DR is going to send. Here, there will be no change. Understood? Right? Okay. Then everybody, you see 2, 3, and 4, everybody acknowledged the DR. Everybody acknowledged the DR VDR. This is LS acknowledgement. Clear? Okay. Then, if you want that, okay, let's say for example, R1 should become the DR. So you just go to the interface gives 0/0. So if I say like right now do show, I can see the priority actually. So do show IP OSPF interface pixels. So on this interface, if I see what is my interface priority right now? 1. Okay. And what is my state? DR. Let's go and change the things, right? Who is the DR? 10.1.1.5. 10.1.1.4 is the BDR. Interface gives 0/0 IP OSPF priority. And you can see I can give anything between 0 to 255. So if I say 255. Okay. Now who has the higher priority? R1. Do show IP OSPF neighbor. Do you see anything? Why? Because everybody already knows about the DR and BDR. So there is no new election. There is no new election. See here. But when the election will happen, if I say do clear IP OSPF process, if I'll clear the OSPF process, recalculation will happen. Recalculations will take place. Okay. So you see with 4 and 5 again it created what kind of neighborship? Full neighborship. Full neighborship was created. Do show IP OSPF neighbor. Still nothing happened. Why? Because DR BDR, this was changed on DR other. So this will remain a DR other only. If you go and check here, R4, do show IP OSPF neighbor. You can see the guy has a higher priority, but still a DR other only. So if DR BDR election is already done and if some new router is coming with a higher priority, DR BDR will not change. Okay, DR BDR will not change. But yes, if you clear process on the DR, let's say if I go and clear the process on the DR, or first let me clear on the BDR. If I say do clear IP OSPF process, yes. Now do you see? It has formed neighborship with 1.1 and 1.5. To show IP OSPF neighbor. The guy became a BDR only. Still no DR. That means if DR is not there, if BDR is going down, BDR election will happen. If DR is going down, DR election. This is clear. If I go here, let's say on the R5, and if I say do clear IP OSPF process, then it will start forming the neighborship. Now this time DR is down. Okay, so everybody will recalculate. Everybody will recalculate. So let's see. Still calculations are going on. Wait for it. Okay. Master slave elections are going on. So if you see this guy again formed full neighborship with 1, 2, 3, and 4 because this is DR. Do show IP OSPF neighbor. Now do you see who became the DR? Clear? And if I say that IP OSPF priority 0, and if I say do clear IP OSPF process, now we'll see what happens. Done. Still exchange is going on. Okay. R5 is the DR, R4 is the BDR, and remaining everybody is DR. So that guy will never become a DR or BDR. Okay. See, because the priority is 0. This is clear. Okay. So let's set it back to 1. And here to show IP OSPF neighbor. So everything looks good. Everything is good. So this is clear. Then let's start configuring authentication. So if I say router OSPF1 and if I say area 0, authentication, enabled authentication. Now if I take a look, let's say if I go and capture the packets on Z0 by 0 of R1. So this is the hello packet, OSPF, hello header. Okay. So right now I have enabled the password I haven't configured. Okay. And if I say OSPF header, you see authentication type is, and authentication data is nothing. There is no password configured. So no password configured means what? Null authentication. This is null authentication. Okay. Now if I go and configure the password, so let's go here and on R1, I'll configure. And see everywhere you see the dead time expired. Why? Neighborships are down. So if I go and configure on R2, let's say router OSPF1, area 0, authentication. Now R1, R2 will form the neighborship. They will form the neighborship and they will have their own DR BDR. Because with others, they will not communicate. Okay. And if you check packets from R3, R4, R5, they have the null authentication. Because we didn't configure authentication. On R1, R2, I configured authentication, so it has taken by default simple password authentication. So when you do not configure authentication, by default it is null. When you enable authentication, that becomes simple password. That becomes simple password. And if you see from others like R3, so this is by default null authentication. This is clear. Let's go and configure the password. You see, they became the neighbors. Now if I go and enable the password, interface gig 0/0 IP OSPF authentication, IP OSPF authentication key, and let's say key is what? Cisco. Now again neighborship will break. Why? Because one side I have set the password. Okay. So you can see here, now whatever the packets will come, right? Whatever the packets will come from, R1 will have the password, right? And the neighborship between R1 and R2 should break. See here, that time expired. Okay. So now they will not become neighbors. See here, that time expired. Here also, that time expired. If I go and enable this side also, interface gig 0/0 IP OSPF authentication, then IP OSPF authentication key. Now they will form the neighborship. Authentication will match. Here, same authentication if I set it to MD5. Okay, let's say if I'll say no and no. And instead of this, if I say IP OSPF authentication message digest MD5. So I'll say IP OSPF authentication message digest. Okay. No, not OSPF authentication. It will be IP OSPF message digest key. message digest key number 1, okay, and MD5, and password is again, let's say, Cisco, right? Now, if we take a look here in the packet capture, so whatever the packets will be coming from .1, this is the packet from .1. This time you can see authentication type is cryptographic, key ID is 1, cryptographic data length is this, and this time we are not able to see the password. This time we are not able to see the password. Let's go and enable the same thing on R2. No. IP OSPF, authentication, message digest, IP OSPF, message digest key 1, MD5, ASS. They will form the neighborship. Clear? Then, if I go here and if I say, no, and if I say that keychain CCNP key 1, key string Cisco, and I'll say cryptographic algorithm is, you can see, HMXA. So let's say I'll use what? HMXA 256. Okay. Then interface gig 0/0, IP OSPF, authentication, to enable the authentication, IP OSPF, authentication, keychain, and what is the keychain name? Now let's take a look. So whatever the packets will come from R1, those packets we will check. If I check this, now you can see this is cryptographic, but this is the large this time, right? Then if you go and enable the same thing, keychain, CCNP, key1, key string Cisco, cryptographic algorithm, HMXA 256, interface gig 0/0, IP OSPF, authentication key, authentication, keychain, and the name is CCNP. Okay, and they will form the neighborship. You see, LS update and all these things are there. Neighborship is there. This is your OSPF authentication. Clear? So we just executed the commands we noted down. Okay. All right. Online people, clear?
Yes, sir.
Yes, sir.
All right. Now your task for the next session is about OSPF virtual link, OSPF LSA types. This is your task. Then after this, we have, this is not a task, these are the topics left. Area types, OSPF filtering, and multi-area will be in the virtual link. Virtual link we are creating because of multi-area only. Okay. Then we will talk about summarization. Two more sessions for. I think Saturday we will need to have a session. Everybody's okay, right? Saturday, one session we will plan. We'll see. We'll discuss in the group and then we'll listen. But I think we have already discussed this thing because we require few more sessions. We'll see. We'll discuss in the group. So tomorrow you guys prepare for virtual link and LSA types. Okay. All right, guys. Then this is it for the day. See you guys tomorrow. Have a good day.